Hey guys, it's Sunday morning. Trick or treat for us. October 31st. I'm just gonna do a quick video, real quick. I dug my E2 out of my garage, and basically, I'm just gonna go over some quick commands and stuff, some navigation type stuff, and that's it. Let's get started. All right, so you guys might need to zoom in. It's the best I could do, though. So down here, you have your F1, F2, F3, F4, and F5 keys. Basically, if you look at the bottom here, you'll see F1 suction. These are the quick keys to basically get you around. There's your home key, alarm key, which should take you back to all the alarm failures. Question mark. That's actually mainly used for two things. So if we go to, let's just go to the suction. And we'll highlight one of the suction groups, the -24. When you're in the setup, one of the things you can use it for, if you don't know, basically, what each one of these programming parameters is set for, like what it's actually used for. So what you can do is basically you highlight, whatever you're wondering what it's doing, what it is, hit the question mark. And basically, it gives you a definition of what that alarm actually does. Another useful thing is you could actually hit shift question mark, and it basically gives you some troubleshooting stuff. There's the resistance temperature chart, so basically tells you the temperature versus the resistance. Shift question mark again. You can do voltage chart, and basically remember with transducers, they basically induce a voltage back to the board to tell it what pressure it is. So if you have for a 100-pound pressure transducer, and it goes all the way up to 100, right? So technically from 0.5 to 4.5 is your range here. So at 2.5, a 100-pound pressure transducer should be outputting 50 psi, and so on and so forth with a 200-pound, 500-pound. So there's just some neat things that you could do with the with the shift question mark. Case defaults, actually how to test or replace the battery. Copeland ISD display codes. And basically just gives you just other things to look for. One of the other things that we have, if we have Alt question mark, these are all the shortcut keys. So a lot of times, like when I'm trying to get somewhere quick, like a lot of people, they memorize the code, and I don't even memorize them, but like I think menu 773 might be to get to the network stuff. But instead of that, I just hit Alt N. Network status. These are just basically just real quick shortcut keys. Alt C will get you the condenser summary. Alt B will get you to the case control summary. Alt K, sensor controls. And we'll get into that in 1 second. Alt T should be the TCP IP. That's going to be basically give you the IP address so you can actually link up to the controller like I am currently. And then these are basically some edit stuff that you can utilize. So if you don't have like the Alt E actually, engaged, what'll happen is, if I try to like edit something, I can't go letter by letter. It won't let me. But if I hit Alt E, Alt Edit, I'm sorry, Control I and Control E. So basically, let me go back to the suction again. So now I can actually, if you look at the cursor underneath where it says system 1 through 24, R404, I'm actually able to go through and, basically go through every single letter so I can actually edit stuff through there. A lot of people, they end up programming through the program that I'm using currently, which is Ultrasight. But some people think that it's faster to program through the controller. So that's up to you guys. So once again, control, insert, and edit. Now I can't go back and forth. I go to hit the left and right arrow buttons on the keyboard, and it basically just takes me, it won't help me scroll through the letters anymore. All right, we also have condenser control. In this particular one, they're having an evaporative condenser. They're doing differential and, basically TD across the evaporative condenser rather than pressure control circuits. It basically takes you to all the circuits associated with, each suction group that's on there. Go to F4. And this brings you to analog sensor controls, digital sensor controls, and an analog sensor control is basically taking a numerical value and making a decision on what it should be doing, right? So if I go to, let's just go to delta discharge. And basically there'd be a numerical value here. And then if I go to the actual setup, taking two numerical values. In this instance, they're just monitoring, basically the difference between the two. And if the differential looks like gets up to 20, so they're not utilizing this to control anything. They're just utilizing it for an alarm, which you can do that. I come down to evap pump. So right here, you can see where the cut in, cut out is 40 and 55, 45 and 55. And then if you go to setup, notice it's only using one sensor. English units, degrees Fahrenheit. If I hit F2, it'll take me to the next tab. It's using this sensor, which is 2.3. If I'm not mistaken, I believe that's ambient. So basically it's going to cut in and out based off of the ambient. Yeah. No delay on that. Notice how we have an M here. This actually stands for multiple. If you actually look here, it says press F4 to hit the multiple out. If I go back over one, see how it doesn't, the multiple out isn't there anymore. So I can actually hit F2 to go back over, and then I hit F4 for multiple out. And it looks like it's turning on and off an evaporative pump proof. I'm sorry, the evap heater, and it's also using an evaporator pump proof. And these are outputs, so this is basically turning something on. Digital sensor control, let's see if we have some down here. Okay, so right here, this is a digital sensor control. This is basically, these are items that are basically making decisions off of, something that's either on or off. So here I have a vibration alarm. Okay, it's looking for an input that's either on or off. And based off of that, it's going to alarm out, I believe, if it turns on. Now, this particular device is on an evaporative condenser. And basically, if the bearings go bad or, the big fan blade breaks on the evaporative condenser, it basically will, tell you that you have a problem hopefully before something massive breaks, right? And then if we go over to alarms, basically alarms, if it's on for more than 10 seconds, then it'll kick on. There are other things in the E2 controller. You go to setup. Menu, configured applications. This basically tells you anything that's actually programmed in here. Suction groups, condenser circuits, sensor controls, flexible combiners, logging groups. So, that's for basically if you're logging the whole controller, for every 2 minutes for a time frame of, maybe let's just say 2 months. But then you want to log something that's maybe a little bit longer, like maybe you might have log a liquid level control, basically just see your liquid level, graph it every, half an hour, every hour, and then basically, utilize that to get, maybe a 365 view, maybe a whole year. So you can see like the ups and downs, see if you have leaks in the system. Analog combiners, basically taking, analog values and combining them, whether it be min, max, you can minus some values. Same thing with digital combiners. Basically, it's taking a digital value. Conversion is going to be based off your refrigerant. So there's our drop leg. So if we had a value in here, okay, let's see if I can do it from here. Let me log in real quick. See if I can override a value here. Yes. 250 pounds. Yeah. So this is basically taking a refrigerant pressure and basically converting it to a saturated condensing temperature on this one. If we actually go to setup on this, you can see pressure to temperature, it's 404. So you gotta remember there's no glide on 404. So, but when you do select the refrigerant type, if you hit, a lot of these menus, the F4 button will actually turn into a lookup button. By hitting F4, you can basically scroll down here. On this particular controller, apparently the firmware must be older because I'm not seeing the newer refrigerants with the glide. A lot of times you'll see, like if you're on 407, you'll see a dew point or a bubble point or a midpoint. There are usually 3 options with the higher glide refrigerants. So that's what conversion factor is. Menu, configured applications. You also have global data. This would be if you had, basically another value, whether it be analog or digital, and basically you could transfer it from controller to controller via Ethernet. A lot of times they'll have, the ambient temperature sensor, light level, especially like if the light level sensor happens to be close to the refrigeration rack, but yet has to be transferred to like an HVAC controller. You can do emergency shutdown. So if, you have a phase loss or something like that, or something coming from the main disconnect panel to tell you that everything is shutting down. They do this a lot with rooftop units where, a lot of times they'll have a phase loss monitor connected to the HVAC controller. And, just for safety, they might spread that to every other single controller. So things basically don't single phase. Add, delete applications. Let's just go through this real quick. So if you look, there's many things that you could, add to this controller. There are some things that you cannot add unless you have a license. License is easily obtainable by, just calling Emerson and, basically giving them what's called the MAC address. MAC address is just a special number that every single controller has. And, you basically give them that number, what you want to add to it, whether it be an S3C or, anything that they're able to do. And as long as you pay for it, they'll give you the license for it. You can also delete applications from here. System configuration. So this is all the inputs, outputs, system information, the logging setup, the alarm setup, network setup, global data. Here's the licensing. Basically says how many items you can actually have on this controller that you can utilize. So standard circuits with the license that this controller actually has, where we can do up to 64 circuits, analog sensor control up to 72, 128 flexible combiners. I'm not going to read every single one off, but basically you get the idea. "99 circuit controllers, OnWorks no limit, core sense." So these are all the things that could potentially connect to this particular E2. 678, 679, 670K, boiler algorithm. Status. So input status, you can basically go here and see every single input. You can also do that as well through the shortcut. So if I do Alt O, that gives me all my outputs. Alt N, once it stops scrolling. Scroll too far. There we go. Now, as you can see, every single board that I have that would have been connected to this is obviously online because the controller's at my house. We can go to Alt M. This basically gives you all the communication stuff. There's the IP addresses, delays for the networks. So if you have a controller that's basically losing communication every once in a while, usually I see standard usually has a 2-minute delay in here. So IONet delay is basically the CPC boards. Modbus would be like your 678, 679 controllers. CMTL is actually Comtrol. LAN delay is Echelon. And if this controller did have the capability to talk to Novar boards, you'd see a NVR delay on here. But guys, that's it. I just wanted to go a brief in and out of some navigation stuff. I promise I'll be getting some more stuff up later. And that's really it, guys. I appreciate your time, and you guys have a good day.